Hello everyone, our project is titled Dynamometer for Stepper Motors and is sponsored by Texas Instruments. The goal of our project was to build a dynamometer to test stepper motors and stepper motor drivers by applying a customizable load torque against the stepper motor. The data that we collect with our dynamometer is the applied torque, position, and speed. The reason why Texas Instruments or others would want to use this dynamometer is to simulate speeds or simulate torques that they may encounter in the real world. For example, printing paper. As the stepper motor rolls, the paper gets less and less, so the torque you need to roll the paper will decrease. So if you design your stepper motor driver accordingly, you can save power by using less current.
The performance metrics of our dynamometer are a maximum load torque of at least 0.27 Newton meters and a position sensor resolution of at least 4,000 counts per turn, which is measured by a rotary encoder. Our frame is able to accommodate both NEMA 11 and NEMA 17 stepper motors.
For our solution for designing this dynamometer, we decided to use a brushless DC motor as the load to act against the stepper motor. As you can see there, both motors are joined together by the coupler. And to function off of the brushless DC motor, we decided to control it using current profiles that are being sent by a brushless DC motor software. So that way, any information from the torque can be sent to the graphical user interface. And also, position and speed are also measured from an encoder inside of the brushless DC motor. And that information will also be sent as well to the graphical user interface.
So our graphical user interface can be seen on the bottom left of the screen. We used TI's GUI composer to make it. We had various toggles and various inputs to switch between torque control and speed control settings, and the output of the torque, position, and speed can be seen on the graphs on the right of the GUI. We had text boxes to extract data for further analysis. And the two graphs on the right show the different torque profiles that we have applied. The one at the top is a ramp profile, and the one at the bottom is a step profile.
So with our team's efforts consisting of Jonathan as our group lead, Katrina as our project manager, Pablo as our hardware lead, and Raisa and I as our graphical user interface designers, we were able to accomplish our goal of creating a dynamometer capable of testing a variety of load torque profiles on different stepper motors. Thank you for your time, and we'll now take any questions.
Any questions?
What kind of applications did you test it on? Like, you mentioned like a paper roller, but what else have you tested it on?
Right now, we've only tested it on just a stepper motor by itself, being able to generate different load profiles for different applications. Example for like a sine wave or a pulse wave when you have it on and off. But as of right now, we weren't able to test anything in the real world. But this is just to simulate.
Yes,
The purpose is to not have to recreate that printer or paper roll situation. You're able to use a different torque profiles to make sure you're actually recreating the environment their customer might need.
So would you use this like in a manufacturing environment to test motors coming down a production line, or to set them coming down a production line? How would you use that?
Yes, you can. It's mostly used in a test setup. So say TI is designing a stepper motor driver, and they want the current to increase as you need more torque and everything like that, or decrease if not enough torque is or if you don't need as much torque to save power. It would be used mostly in that setting, or it can be used to also get motor characteristics and test stepper motors.
Since you had a program manager, is there any specific type of program dynamics that you use within the team? Like, as you're preparing to go into industry that's using certain things like Scrum and Agile and various other techniques, were any of those used during the project?
We coded everything for the software in Code Composer Studio, which is a TI product.
The question is about team management.
Project
management.
In terms of project management, we use Gantt charts for each semester so that each team member knows what they should be working on. That was the main organizational tool we used. We just had weekly meetings so that we would update our mentor as well as each other. That answers your question.
Right. You had one more?
Do you have a stability problem there? Do you have a stability problem in the system or not?
Usually, There was no stability problems, except for when the brushless DC motor overpowered the stepper motor. The stepper motor is not meant to run in its reverse direction because it try to increase its current all the way, and so in that case, it would go haywire, or it would the stepper motor would shut off.
And we also had conditions in which the stepper motor will also stall at certain torques, so that's when we knew we would hit the limit of the stepper motor.
But otherwise, it stays consistently with the intended torque, which is shown in the blue line, and the red, which is the actual torque being outputted.
Right, let's thank the team.